Hello friends, in this lecture we'll see some examples on linear dependence and linear independence as well as solutions of linear difference equations In the last lecture we have seen what is meant by Casortian and how you can use the Casortian. The Casortian means what? Casortian is the determinant of first row is u1, u2, u3 and so on. Then u1 t plus 1, u2 t plus 1, u3 t plus 1 and so on. And in this way, that is the Casortian. What is the use of it? The solutions of difference equations are linearly independent if and only if the Casortian of these solutions not equal to 0. Now we will solve some examples those type here. Okay, show that u1t, yes, okay, we have seen this example in the last lecture. Show that u1t equal to 2 to the power t, u2t equal to 3 to the power t are linearly independent solutions of u of t plus 2 minus 5 times u of t plus 1 plus 6 u of t equal to 0. What is that example? U of t plus 2 equation is u of t plus 2 minus 5 times u of t plus 1 and then what? 6 u of t plus 6 u of t equal to 0. Okay, we have to show that u1 of t equal to 2 to the power t and u2 of t equal to 3 to the power t are linearly independent solutions of this equation. Now we will prove it how they are linearly independent solution. First of all, we will show that these two are the solutions only. So let u1 of t equal to 2 to the power t. Therefore, u1 of t plus 2 minus 5 times u1 of t plus 1 plus 6 times u1 of t equal to. If this is equal to 0, then we can say that this u1 of t given by this 2 to the power t is the solution of this equation. Okay, so it is equal to. Now what is u1 of t plus 2? It is 2 to the power t plus 2. T is replaced by t plus 2 minus 5 times 2 to the power t plus 1 plus 6 times 2 to the power t equal to. Now 2 to the power 2 t plus 2 is 4 into 2 to the power t, because 2 square into 2 to the power t is there, minus 5 into 2, 10 times 2 to the power t and plus 6 times 2 to the power t. So 6 plus 4, 10 times 2 to the power t minus 10 times 2 to the power t equal to 0. Thus u1t satisfies this equation and therefore u1t is a solution of given equation. Similarly, we will go for u2t equal to 3 to the power t. Now, u2 of t plus 2 minus 5 times u2 of t plus 1 plus 6 times u2t equal to. Now u2 of t plus 2 is 3 to the power t plus 2 minus 5 times 3 to the power t plus 1, right? And plus 6 times 3 to the power t equal. Now 3 to the power t plus 2 means 3 square into 3 to the power t, that is 9 into 3 to the power t minus 5 3 15 into 3 to the power t and plus 6 into 3 to the power t, which is equal to 9 plus 6 15 times 3 to the power t minus 15 times 3 to the power t equal to 0. Thus u2t equal to 3 to the power t satisfies your this equation u of t plus 2 minus 5 times u of t plus 1 plus 6 times u of t equal to 0. Therefore u2t, this implies u2t equal to 3 to the power t is a solution of given equation, given difference equation. Now we want to show that once we prove that these two are the solutions of difference equation, then we can prove these solutions are linearly independent if and only if their Casortian is not equal to 0. So now W of t is equal to determinant of u1t, u2t, u1t plus 1, u2t plus 1 equal to determinant of what is u1t, 2 to the power t, u2t 3 to the power t, u1t plus 1, 2 to the power t plus 1 and 3 to the power t plus 1, which is equal to, right? Now I will write this as 2 to the power t, 3 to the power t, 2 into 2 to the power t, 3 into 3 to the power t, which is equal to 2 to the power t into 3 into 3 to the power t. So we get 3 into 2 to the power t into 3 to the power t minus 3 to the power t into 2 into 2 to the power t. So we get 2 into 3 to the power t into 2 to the power t. So we get only 2 to the power t into 3 to the power t. I can also say that it is 6 to the power t. 2 3s are 6. And this is never equal to 0 for any t, where t is a plus 1 and so on. There is no t where 6 to the power t equal to 0, and therefore this is non-zero. So Casortian of these two are the solutions and their Casortian is non-zero. Now this implies u1t set u1t u2t, this set is linearly independent, or u1t and u2t, these two solutions of given difference equation are linearly independent. So that is the proof there. So we found wt, they are linearly independent. Okay. Now I will skip this example. Okay, find the, no, we will take this also. Find the unique solution of same equation u of t plus 2 minus 5 times u of t plus 1 plus 6 times u of t equal to 0. And we have given these two conditions now. We have given these two conditions. Okay, these two are the conditions. U at 3 equal to 0 and U at 4 equal to 12. Now in above example, we proved that u1t equal to 2 to the power t and u2t equal to 3 to the power t are linearly independent solutions of given equation. What is the given equation? This is the given equation, u of t plus 2 minus 5 times u of t plus 1 plus 6 times ut equal to 0. Same is here. So we know that u1t equal to 2 to the power t and u2t equal to 3 to the power t are linearly independent solutions of above equation from that example. Okay. Now we know that if u1t and u2t are two solutions of any difference equation, then c1 u1t plus c2 u2t is also solution of same equation. Hence, we can say that ut equal to c1 2 to the power t plus c2 2 to the power 3 to the power t, where c1 and c2 are arbitrary constants, is a general solution of given equation. Is a general solution of given equation. So, which result we use there? I think we have used somewhere here. If u1 up to un are linearly independent solutions of nth order difference equation, then its a general solution can be written as c1 u1t plus up to plus cn unt, c1 u1t plus up to plus cn unt for some constant c1 c2 up to cn. So by using this result, we say that, what we say here, that we say that, where it is, okay, we say that, yes, ut is equal to c1 2 to the power t plus c2 3 to the power t, where c1 and c2 are arbitrary constants, is again a solution. Now we have given two conditions. One, u at 3 equal to 0. This is the first condition. U at 3 equal to 0. U at 3 equal to 0. So by putting t equal to 3, what we get? If I put t equal to 3, 2 to the power t plus 3. 2 to the power t plus 3 means 2 to the power 3 into 2 to the power t. That is 8c1 plus 27c2. Here because 3 to the power 3. Right? What is 2 to the power t? T is replaced by 3. 2 cube is 8c1 plus 3 cube 27c2 equal to 0. We get first equation. Similarly, using second condition, you add 4 equal to 12. We get, by putting t equal to 4, 2 to the power 4 means 16 c1. 3 to the power 4 means 81 c2 equal to 12. This condition is given. So solving these two equations simultaneously, where we arrive, 16c1 plus 54c2 equal to 0 and 16c1 plus 81c2 equal to 0. Multiplying equation number 1 by 4 by 2, we get this one. Now eliminate these two, taking subtraction, 54 minus 81, that is minus 27c2 equal to minus 12. Therefore c2 equal to 12 upon 27, that is 4 upon 9. So put C2 is equal to 4 upon 9 in either of these two equations. We get 8C1 equal to minus 27C2. That is minus 27 into 4 by 9. So we get 9 3s are 27. So 8C1 equal to minus 12. C1 equal to minus 12 by 8. Therefore C1 equal to minus 3 upon 2. And therefore U of t becomes minus 3 by 2 into 2 to the power t c1 u1 t plus c2 u2. This is the unique solution of given equation. Unique solution of given equation. Okay. So once you know the linearly independent solutions, you can verify whether they are linearly independent or dependent by using Casortian, and we can also find its a general solution by considering C1U1 plus C2U2 plus C3U3 and so on. And if we have given some conditions, isn't it? If we have given some conditions, then we can find the values of those arbitrary constants, put the values of those arbitrary constants in again C1U1 plus C2U2, we get the unique or required solution of that difference equation. We get required solution of difference equation, right? Second, next example is like this. Show that u1t is equal to t square plus 2, u2t is equal to t square minus 3t, and u3t is equal to this 2t minus 1 are solutions of delta cube u of t equal to 0. So this is the summation difference equation we have given, and we have to show that u1, u2 and u3 are its solutions. Again method is same. What that method is, or how we can show that these are the solutions of that is in A. How we can show that? We will prove that delta cube of u1t equal to 0, delta cube of u2t is also equal to 0, and delta cube of u3t, it is also equal to 0. Once you prove it, you can say that they are all satisfying this difference equation. Therefore, they are all solutions of this equation. Secondly, what we want to find? Compute the Caucasian of the functions in A and determine whether they are linearly independent or not. We know that if Caucasian is equal to 0, then they are linearly dependent. If Caucasian is not equal to 0, then they are linearly independent. Now we will again solve this one by one. Let u1t is equal to t square plus 2. Therefore, delta u1t. How you can find delta u1t? How it is 2t plus 1? We know that if u1t is t square plus 2, your delta u1t is what? Delta u1t is t plus 1 whole square plus 2 minus t square plus 2. U of t plus 1, u1 of t plus 1 minus u. And what is it? T plus 1 whole square is t square plus 2t plus 1 plus 2 minus t square minus 2. 2 gets cancelled, minus t square plus t square. So we get 2t plus 1. Now, if I find again it's a delta, then we get 2 into t plus 1 minus 2t plus 1, and therefore we get delta square u1t as 2. As this is a constant term, its next delta becomes 0. So delta cube at u1t equal to 0. So by u1t, this equation is satisfied. And therefore u1t, which is given by t square plus 2, is a solution of that equation. Okay. Similarly, u2t equal to t square minus 3t. u2t equal to t square minus 3t. So delta u2 is equal to, again t is replaced by t plus 1 minus t is replaced by t. So if I replace t by t plus 1, what you get here? u2 t plus 1 is t plus 1 whole square minus 3 into t plus 1 minus in bracket t square minus 3t. Now what you will get? T plus 1 whole square means t square plus 2t plus 1 minus 3t minus 3 minus t square and minus plus 3t. So plus 3t minus 3t 0 minus t square plus t square cancel, 2t plus 1 minus 3, 2t plus 1 minus 3, which is 2t minus 2. If I take again its delta of minus 2 is 0 and delta of 2t is 2 only. So delta square u2t is equal to 2 and delta cube u2t equal to 0. Delta cube u2t equal to 0. Therefore, u2 given by t square minus 3t is also a solution of delta cube ut equal to 0. Delta cube u of t equal to 0. Similarly, we will go for u3t. Let u3t equal to 2t minus 1. Therefore, delta u3t equal to 2. It's a difference, will be 2 only. As this is a constant term, its delta becomes 0, and 0, delta of 0 is again 0. So delta cube u3t is again 0. So u3t also satisfies given difference equation delta cube ut equal to 0. Therefore u3t given by 2t minus 1 is a solution of delta cube ut equal to 0. Hence we prove that u1t, u22, u2t and u3t are all solutions of this delta cube ut equal to 0, which is the third order difference equation, and no doubt it is linear equation. How we can write delta cube ut? We can write it as u of t plus 3 minus 3 times u of t plus 2 plus 3 times u of t plus 1 and minus ut equal to 0. Actually this equation can be written in this way also. Okay, it is like that. Now by using Caucasian, we will show that these three solutions are linearly independent. These three solutions are linearly independent. What we want to use? We want to use a Casortian here. So now we will find Casortian. Wt is equal to t square plus 2, t square minus 3t, 2t minus 1. Second row 2t plus 1, 2t minus 2 and 2. Why? Because delta u1t, already you find it. Delta u1t is 2t plus 1. Right? Delta u2t, 2t minus 2 and delta u3t 2. So that will be the second row. What will be third row? Delta square u1t 2, delta square u2t 2 and delta square u3t 0. So that is it. Okay. Now we know how to find determinant t square plus 2 into this cross multiplication, that is 2t minus 2 into 0 minus 2 into 4. So t square plus 2 into bracket 0 minus 4. T square plus 2 into bracket 0 minus 4 minus t square minus 3t into bracket this into this 0 minus 4 again and plus 2t minus 1 into bracket product of these two minus product of these two, 2t plus 1 into 2, that is 4t plus 2 minus 4t plus 4, 4t plus 2 minus 4t plus 4. So it is equal to minus 4 times t square plus 2, that is minus 4t square minus 8, minus 4 times minus of t square minus 3t, that is plus 4t square minus 12t, because minus minus plus and then minus, and then 2 plus 4 6, 6 into 2t 12t minus 6. So minus 4t square plus 4t square 0, right? Then minus 20 plus 20 vanish. So only we get, what about this one? Minus 8 minus 6. What you will get? Minus 8 minus 6. Correct. Minus 8 minus 6. So what is it? Minus 8 minus 6 is what? It is not minus 2. It is what? Minus 14. Minus 14, which is not equal to 0. It is not equal to 0. Hence, the three solutions u1, u2 and u3 are linearly independent. Hence, these three solutions are linearly independent. So in this way, you can show that whether the given solutions are linearly independent or not. Again, one more example of the same type. R u1t equal to 2 to the power t cos of 2 pi t upon 3 and u2t equal to 2 to the power t sine of 2 pi t upon 3 linearly independent solutions of this equation. We want to now verify that or now conclude that, isn't it? Whether these two are the linearly independent of this equation or not. Again, the same method is there. First of all, you see that whether this satisfies this and this satisfies this. Once they satisfied, go for Ransky, Casortian, and verify that whether these are the linearly independent or. So first of all, so I will go for u1t. So first of all, we will see that whether u1t satisfies this or not. Therefore, I will find the value of u1t plus 2 plus 2 u1t plus 1 plus 4 u1t. If it is 0, then u1t is the solution of this one. u1t plus 2 plus 2 u1t plus 1 plus 4 u1t equal to 2 to the power t plus 2. Why? Because u1t plus 2, u1t is what? 2 to the power t cos 2 pi t upon 3. So 2 to the power t plus 2 cos 2 pi t plus 2 upon 3 plus 2 into u1t plus 1, 2 into 2 to the power t plus 1 cos 2 pi t plus 1 by 3 plus 4 times u1t, 2 to the power t cos 2 pi t upon 3. So here 2 square 2 to the power t means 4 into 2 to the power t cos of 2 pi t plus 2 by 3, that is 2 pi t by 3 plus 4 pi upon 3. So cos of 4 pi by 3 plus 2 pi t by 3. plus 4 times 2 to the power t, here 2 into 2 to the power t, cos of 2 pi by 3 plus 2 pi t by 3 plus 4 times 2 to the power t cos of 2 pi t by 3 as it is. So this is equal to 4 into 2 to the power t. Now you are using here cos of alpha plus beta. What is the formula for cos of alpha plus beta? Cos alpha cos beta minus sin alpha sin beta. So same formula we have used there. So you will get cos 4 pi by 3 into cos 2 pi by 3t, 2 pi t by 3 minus sin 4 pi by 3 into sin 2 pi t by 3. Similarly, what about here? Now, here is 4 into 2 to the power t, here is 4 into 2 to the power t, here is 4 into 2 to the power. So you have taken 4 into 2 to the power t as a common. So into whole bracket, second cos of 2 pi by 3 into cos 2 pi t by 3 minus sin of 2 pi by 3 into sin of 2 pi t by 3 plus cos of 2 pi t by 3. So we will get 4 into 2 to the power t into bracket. What will happen? Now, cos 4 pi by 3 is minus 1 by 2. So I will write minus 1 by 2 cos 2 pi t by 3 plus sin 4 pi by 3 is root 3 by 2 minus root 3 by 2. So it will get plus root 3 by 2 sin of 2 pi t by 3. Cos 2 pi by 3 is again minus 1 by 2. So minus 1 by 2 cos 2 pi t by 3. Sin 2 pi by 3 is minus root 3 by 2. Therefore, sin 2 pi by 3 is root 3 by 2. Therefore, minus root 3 by t sin 2 pi by t plus cos 2 pi by 3. So if we now solve this, plus cancels it, minus, right? Minus 1 by 2 into cos 2 pi by t, 2 pi by 3t, minus 1 by 2 into cos 2 pi by 3t is only minus cos 2 pi by 3t, and here it is plus cos 2 pi by 3t, gets cancelled. So in all this use is 0. So u1t satisfies given equation. Similarly, we can show that u2t also satisfies the same equation. So what we want to again prove there for u2t, u2t plus 2 plus 2 times u2t plus 1 plus 4 times u2t is equal to, it will comes equal to 0. Therefore, we can show that u2t is also solution of same difference equation. Now we shown that u1t and u2t, these two are the solutions of given difference equation. I have a little homework for you. Show that this u2t is the solution. So you have to verify it. Okay. Now we'll find Casortian. So if we find now Casortian, 2 to the power t cos 2 pi by t by 3, 2 to the power t sin 2 pi by 3 t, then 2 into 2 to the power t into minus, it's a delta we have taken, minus 1 by 2 cos 2 pi t by 3, and here we have to take delta of this term or replacing t by t plus 1, and if we solve it, we get it as equal to non-zero. It is equal to non-zero. How we get non-zero? We will verify it. Determinant of first 2 to the power t cos of 2 pi by 3t, 2 to the power t sin of 2 pi by 3t. It's a shift by 1. 2 into 2 to the power t cos of 2 pi by 3 t plus 1. And this is 2 to the power 2 into 2 to the power t sin of 2 pi by 3 t plus 1. Such types we are taking. Okay. Now, which is equal to, so 2 to the power t is common in all these. Okay, I will take 2 to the power t into determinant cos of 2 pi by 3t sin of 2 pi by 3t Actually 2 to the power t into 2 to the power t. I will take common from first column as well as common from second column. So we get here 2 into cos of 2 pi by 3t plus 2 pi by 3 into 2 into sine of 2 pi by 3t plus 2 pi by 3. It is like this. Okay. It is like this. Now, which is equal to? Are these two? So, are these two are there? Yes, 2 to the power t cos 2 pi by t3 and 2 to the power t sine 2 pi by 3. Okay. Now this is equal to, I will write 4 to the power t into determinant. So you will get here 2 into cos of 2 pi by 3t into sine of 2 pi by 3 plus 2 pi by 3t minus, right, 2 times sine of minus 2 times sine of 2 pi by 3t into cos of 2 pi by 3 plus 2 pi by 3 t. Bracket is closed. Bracket is closed. I will insert one page there. Okay. Yes. Add the page. This is our second page. Okay. What about first page? This is the first page. Here. So what will be the next page? Next page becomes 2 again take common. 8 into 4 to the power t into bracket. Cos of, or I will take 2 here. Cos of 2 pi by 3t sine of 2 pi by 3t plus 1 minus 2 sine of 2 pi by 3t into cos of 2 pi by 3t plus 1 and bracket closed. So you are getting here something cos alpha sine beta minus sine alpha, sorry, minus cos. So if I consider this as alpha, I will write this as alpha and this as beta, right? So you will get this as alpha, this as beta. So I will take 2 here and these 2 will be cancelled. So 2 into 4 to the power t into bracket. Cos alpha sine beta minus sine alpha cos beta. We know it is the formula for, see here, cos alpha sine beta cos alpha minus cos beta sine alpha. It is the formula for sine of beta minus alpha. That means 2 pi by 3 t plus 1 minus 2 pi by 3. This t. 2 pi by 3 t. So this is equal to, what will happen there? This is equal to 2 into 4 to the power t sine of, what you will get here, 2 pi by 3t minus 2 pi by 3t. So only we get 2 pi by 3. And whether sine of 2 pi by 3 is 0? No, it is not equal to 0. 4 to the power t not equal to 0. 2 pi by 3 means what? Which degree angle is there? 2 into 4 to the power t sine of 2 by 3 into 180 degree. Right? What is it? It is something 120. So 2 into 4 to the power t sine of 120 degree. Sine of 120 degree is not equal to 0. Therefore, the Casortian is not equal to 0. The Casortian of the given is not equal to 0. And since Casortian is not equal to 0, it is linear. These two are the linearly independent solutions of given equation. Hence, by using Casortian, you can verify that whether given solutions are linearly independent or not. But keep in mind that before use Casortian, we want to verify that whether given sets or given functions are solutions of given equation or not. That is important. Okay. So these are the examples of difference equation on or which in which we use Casortian of functions. We use Casortian of functions. Okay. And we use some results. Which results we have used here? These two results we have used. First one is this one is one result. If u1 up to un are n solution, then the linear combination is also a solution. And this one, previous one, what was that? The solutions are linearly independent if and only if their Casortian is not equal to 0, or the solutions are linearly dependent if and only if their Casortian is equal to 0 for all values of t. So for this session, we will stop here, and in next session, we'll go for other.